to everybody. Can you hear me? Everybody, everybody, can you hear me? Everybody, close this up. Everybody, this goes there. And what did we have here actually? Had some from no? Did have yes, and we did have our development guy. We did have it on the right. Yes, yes, yes. I could have my ones here. Hello, how are you feeling today? Like, I'm glad you're good. Uh, doesn't work. What if we have it? Let's see. Okay. Project. Guys, what did I achieve? Let me show. What did I achieve? In the meantime, let's turn OpenGL guy here. Okay. What did we achieve in the meantime? I was trying to get normal data in the GPU, and I've managed to do that in an ugly way, I would say, but I have done it. You see, I have a draw data that looks like really ugly being. No offense to anyone, but what I am doing here is I create a struct triangle here, and this triangle has three vertices, three normals, which comes from the vertices, and I have the texture coordinates in the UVs, and after I assign these in the triangles here, I push them back. I place them back in the triangles vector of the primitive that uses a lot of resources, by the way, but it's fine right now. And after that, we have to move this data from the triangles to the draw data, just pass to the GPU with this GL buffer data command, and this yeah, that's basically it. So we can pass data to the GPU right now, the normal data. Let's see how our like how the Suzanne looks like. I have changed the Suzanne to a cube, but I can't do it. I know triangular prism is not the Suzanne, but I have named it triangular prism, so we are going to have to live with that. Let's start the guy. Okay. Yes, the monkey seems a little bit nice here. I might say the color you see, guys, here is the normal data. It means the normals color is simply the normals. Yes, the normals of the triangle. So it seems seems like alike in the top of the Suzanne, and for example on the forehead of the Suzanne it is also a little bit same, because like normals of the triangles show the way. And on the right hand side we have like red normals, because the normals show this way. And on the left hand side we have black. Camera movement is a bit weird, because like this goes a lot third. Yeah, okay. Okay. What I don't understand here is why normal data does not change with the rotation, because it should change. I think I know why, because the what do you call it, the rotation is achieved with the model view with the model matrix, and it doesn't change the normals. No, it simply multiplies the position. So we have to also maybe we have to think about it, because we don't translate, we don't transform, we don't rotate the normals yet, because if you see the model view projection matrix only is multiplied by the with the pos, the normal value doesn't change. And there is a concept that we cannot use the model view projection matrix to transform the normals, because then they will be a different normal. I think I can show it here in somewhere. Here, see, the scale changes the normal too, but you cannot use the normal, the scaled normal, because it's not the same normal. Yeah, if you apply transformation to this normal, the same transformation, the scale transformation, it will be wrong. Should therefore apply a different model multiplication to the normal. That is transpose inverse, the transposed and inversed model matrix. You have to apply this transformation in order to transform the normal along with the normal vertice. So we have passed the normal data to our vertex shader, so we can start with calculating the diffuse color, and we have to get the light position for that though, because if you don't know where the light is, you can't show anything. You can't reflect any light, because like mentioned in the previous section, color can only then be showed if there is nothing in the way of between the object and the light. Therefore, we need the position of the light. We need to see the light in order to show something, and the showing part was the diffuse part of the material of the object. Okay, we have done it already. GL position. We have transformed our position with our MVP matrix. And what is this? This is simply this is the world coordinates of the position, because it only and only multiplies with the model matrix. Do we need this? I think we need world coordinates, because we need to be able to change the color based on the world coordinates, the fragment shader. Okay, then we have to create another uniform variable here, and under the MVP one, and we call it uniform math for model. Oh, yes. Okay. Uh, We are going to have to push this model matrix to the GPU. How are we going to do that? Uh, the main file, because we are setting the matrix here, and we need to set a matrix here, but the MVP is set by this. Okay, we just need to set the model. Shader set matrix. Name of it was model. Yes, I don't know. Non-case letters. Okay, float. Cast it to float address and call MV, for example, for the sphere. And for example, for the what is this? This is the 10. And shader set matrix model and do it with float. Simply the model. Yes, and with one last time. Do we need to do it for the light? I don't think so. Don't need lights. Lights. How do you call it? Normal data. Because why would you need those? Okay, we have our model matrix here, and after that, we can define an output variable here. Output variable vec4. I will call it, and this is going to be a fragment position word pos. I'm going to type it in word pos. Let's call it vec3 and normal that out, and let's call world pos equals, call it vec3 created by a model times vec4 pos 1 created by model and pos4. Yes, this should be it. Model is a 4x4 matrix and pos4 is 4x1 matrix, so we get 4x1 matrix at the end, but we simply discard the last component like it's being done here. And afterwards, it simply sets the normal and sends it the fragment shader. It does the shading in the fragment shader. So instead of saying color here, we are going to say normal in the output variable, uh, and say normal equals vertex. This is not, yes. First, let me see. Working, but how is the color even defined in the fragment? Simply color, but we don't have any input. How can file actually? What? How did it compile correctly though? Because this is for formal now. Why did it compile correctly? Started? I don't know, the shaders don't get updated. I honestly don't know why. Now we still see the colors and the shader code is like this. Okay. Why don't you update the shaders? I don't know. It's open from the Visual Code, maybe. Explorer. It starts. Vertex. It. Shaders. Okay. Function though. I see. I need source files. I need field files. Okay, okay. What is learning C? Field files, source files, and header files. Shaders. Weird. See. How do we update shaders? Yes, because it's still using the alt shader. Okay, I need to change those. They're not my shader. Get relative font. This is in source, and I have to one up and go into shaders. Then start. Let's see. Shaders. Shader frag. Dot. Shader. And do it for this too. Right shade frag. Normal equals vertex normal. And this should be our fragment vertex shader. Normal equals vertex normal, so it functions now. And I'm going to code base. Fix shaders. Shaders. What do you call it? Shaders. Path issue maybe. Oh please. Okay, I'm going to little bit coming in a bit. I am Beccherino and are ready, Erino. Let's go. Our shaders are working. Okay, we can follow the tutorial. And let's add the corresponding table. We did those. Normal. Okay, this shows it. Okay, do we need to normalize it? Let's see. I think we need to normalize it. Yes, this is right. Let's call a vectory normalize world normal equals normalize it, man. Normalize that mother flipper. Normalize those with those. Normalize those, and we are going to use world normal here. And I think we are going to see a lot of something different here. No, I think it seems like they were already normal. There. Okay, they were already normalized. Let's see light direction. This happens in the. This happens doesn't happen in the output variable, but in the uniform. Simply get those two here. Say those, and after that we simply get this. Write it here. This is light color. What's distance? Distance 2. Distance 2. Where is the world position? We need world position. It's all vectory world position. In vectory world position. This, then a done decision. World position. How did I write it? Yes. Okay. In our shader, we have now world pose, but this is a vec4. Oh, wait a second. The world pose. Okay, we just create a vec pose for this. Yeah, vec for world pose, and 1 0 f. It's a position of the direction. Okay, and our vertex shader looks like this. We have created our world pose. Okay, and the distance between these two needed, and it light pose minus drag pose. It doesn't matter because it's a distance function. It simply, when calculating lighting, we usually do not care about the magnitude of a vector. Oops, what's the thing? Of a vector or their position. We only care about their direction because we only care about it. It simplifies most calculations like the dot product. So when doing lighting calculations, make sure. Okay, let's see. This doesn't ask for the distance. It simply asks because we're going to calculate the diffuse component. You need the direction. We're going to say vectory light direction here, and simply call what is that? We're going to normalize it after. After do this light position minus phosphor, this should be vectory. We don't need the last coordinate because light position also has 1 0. This also has 1 0 in the last component. So and the direction has this, and the distance. Okay, we keep the distance. Keep the distance. And afterwards, there is some lighting theory here. No, there is no. There is some lighting theory here. And yes, this diffuse thingy is created by the dot product. of the normal and the light direction. And this should be a positive, that's why here there is a max and 0, 0, because otherwise there would be negative lighting, and there is nothing as such as negative lighting. So the diffuse component is calculated by the direction of the light, by this one, and the theta and the angle between the normal and the direction of the light. So we have normalized this, and we have normalized our world normal. So we can simply say diffuse component is this max dot light direction and world normal, and afterwards we just call 0.0 f, and this should be our diffuse component. Afterwards we can multiply this diffuse component with a anything here. This diff times light color. Okay. Uh, let's do it, I guess. This is a diff component is equals to diffuse times. I don't think we need it right now. But let's do it like this guy. Factory actually, because I don't need the alpha value right now. And yes, okay. Okay, diffuse. Because you simply calculate it in the diffuse again. And what is ambient here? Ambient should be defined somewhere. And ambient is the color of the object, so we can define it in any way we want. Here is lighting. And how does it? Ambient strength times light color. So I'm going to use my material file here actually. Where is it? Assets. Wait a second. How do you find the assets actually, man? This is so weird, no? You have to find the assets. Aha, because this is object file. If you download the code, you won't be able to find it. The object file should be again. It is dot dot. We go one up. Go one up. We are in the here, and we go. Yeah. Okay. Let me open the material file, and as we see, the ambient term simply 1. So the ambient strength is 111. Okay, let's open Blender here, I guess, and how does it look like? How it looks like if we were to change anything in the Blender, I yeah, can do something here. I don't know. I don't Blender. Uh, for here, material actually. Something here. There, material surface color is. I don't want the. I don't know actually what's happening. I would love my guy looks like this. My model. Hello. whatever. We're going to come to that later. Let's see if we can render anything right now. I'm just going to go with 1.0 here. I'm going to hard code it. I don't care. Let's see, ambient strength is 0.1 here. Ambient. Okay, the ambient strength just calls down the color, you know, but we don't need to call ambient dot object color. Don't want to call the color, you know. Result should be then the object color of the object. And I'm going to hard code it, and I'm going to make every object look like they are some kind of. I'm going to open the browser again, see what color it was. It is fine. Okay. Material tab, material girl. Where is material? Girl, open it. Come on. Something. Material girls in the chat. Okay, I've opened it. And let's set the base color here, guys, and see how it looks. Color, like this color. What's color? RGB. Let's copy it. Color. Colorful. Victory. This. That. Do value. Okay, yeah, we can close. Don't save. Okay. This is our color. It is hard coded. And if I were to, I don't need to, I don't need to, have to, I need to find the color. I don't need to do that. Because the light color is always 100. I don't need to do that. And afterwards, can simply do this and call this component is this. And I can simply say okay, this has the light color in it. This also does have the light color in it, but my my ambient term is 1, so my brain stopped working. The diffuse component is the diffuse part which multiplied with the light color, so and ambient component should then be ambient component is 1 for me multiplied by with the light color. So what do we have here? We have ambient plus diff times light color. So we can simply say this here. Vec results equals to light color, vec3 of light color, because it is 1, the ambient term was 1. Vec3 of light color plus diffuse component times object color, which is colorful. So, and the result should then show here. It should see something like this, Let's see if it functions. We we want it to function. Okay, it doesn't, of course. Why should it? Uh, everything painted. Everything is painted the same. It's colorful. Called white color. And let's say let's just define the ambient too. So we are not fine way, skip steps and load strand. We don't need that. We are going to we need that. We need that load strand. Let's call it 0. Let's call vectory ambient and time light color. But it's not. And after that, okay, that it to positive colorful. Okay. Let's see what it looks like here. Okay, it looks like we are doing something right. Because you see some areas that see light different. I'm going to down the strand here. Okay. A lot better actually, no? This looks like it sits in a poorly lit area. That's okay, but I think are we passing the light position? I want to looking for light position. Light position should light position dot x. This is actually how do we see light position? Ask light cube light should actually set it here again. It's set here. Okay, then it should work. It's the translation. It's in the world coordinate. Let's include specular lighting too. To do that, we're going to inverse our normal, transform our normal done by the inverse transpose multiplication with normal. Do this in our vertex. Simply copy this code, type it, say symmetry transpose inverse model, or comes back to met the word just now our normals are also transformed. So if it's not rotating, it won't change anything because model is 1, 1, 1, and it's rotating, it will change something. Lightning should change with the cube, with the rotating sphere, but it's so bad. Change the rotation angle. Transform angle should be something. But it's still rotating too fast because it's still rotating. Say 75. Dot full. And I will rotate it that I want place. I want to rotate it in place. How do I achieve that? This is too slow. It's the wrong angle. See that? Lighting change. The lighting change. I don't see it. Lighting change. You don't you see the side that sees the camera lighted and the side that doesn't. Rotate. Maybe the angle is okay. I know. I think because I translated translation. Translation is here, here. The models because I translated and rotated. Rotate and translate. It doesn't matter. Doesn't matter. Wrong with the rotation. Rotation. With the rotation. I'm always hard dip. It's not hard, but I don't want to use my that much. Okay, I'm going to leave it. I will change it again. Does it? I should not do this, but I don't understand is does it make big uh, so big rotation? Why it doesn't happen place? My part is correct. The angle. What's the best is one? Back to 1-0. Like it. And we're done with it. Okay, the rotation functions, as you can see, the normals are transformed along with the rotation. The changes split. Okay, so it seems like the monkey, the light from behind, because the light position is off. But we don't care. We are going to do specular lighting right now, and this is there is the third component of bidirectional reflectance beyond function. BRDF. This is specular, like you see something metallic when you project something with light, and you see the light back. This is called specular, and this changes with the light with the view position. Now this should change with the view position because if you look at, if you look a little bit in a different angle, it should change. It is worlds like that. Physics works like that. So therefore, it finds. Therefore, we need a view, the camera position. Therefore, we're going to need another uniform variable. We don't need a vertex shader. We're going to need it in the fragment shader. Call it uniform vec3 view of pos. It doesn't matter if I call it vec4 or vec2 because we are using coordinates anyway. And let's set this up. To find it, we're going to need we're just going to need the camera position because we are going to calculate camera position to the fragment position. This is the camera position. get it from the camera. Get it from the camera, and here after we say shader, we are going to have to say it vec4 because we don't have any vec3 setters. That color, okay. Origin X, camera, origin, camera, origin D, and other one 0F because homogeneous coordinates. And we set the vector for, and we are going to define a specular strand here in the fragment shader, vertex shader. Here we can do it after the use component and define a specular strand. Let's call it 0.5 like the guy. And afterwards we need to find the view direction. This happens, we simply drag pause around, normalize, view pause minus pause is our view direction, and we need to calculate the there is actually a reflect function. The reflect function expects the first vector to point from the light source towards the fragment's position, but the light director is pointing the other way around from the fragment towards the light source. To get the correct reflect vector versus its direction, I negate light direction vector first. Light and normal light. Okay, so then call vector reflection reflect function direction and normal world normal. This reflects it, and afterwards we need to have a component and component. We're just going to type this formal in. Theory behind it doesn't really matter. Direction action for 0 dot of specular strand. Have it. We have spec and we have light color. Okay, and afterwards we have to edit to result. Last result. And try for the intent component specular. This is basic function. Something's wrong. Implicit cast from vec4 to vec3. Of course, which what is yes. Some metallic hue here. Something you can see transform here, but it's wrong. Yeah, it's wrong. It shows the other way. No? Shouldn't be specular right here. It should be there. Because maybe though. Wrong though. It it's the or maybe the color isn't okay for this. Diffuse. Let's go 100. Direct. Back for world pause. This is also then like get it wrong. Why does it show? Shouldn't show direct action, action, I know. It's okay. Let's keep going. Next chapter. Implemented the basic lightning thing. Material. Okay. Okay. We don't chapter right now. Yes, this should be helpful, but I don't know how to open the material things. Good. See you. Looks good. What is lighting maps? Okay. Okay. Could use this. Could maybe use Lightcaster. Okay, maybe have more light sources here. Okay. I don't want to get like right now. Light section. I've done it. Okay, we go. I think we're going good. We're doing great here. And just after when I'm done with lighting capital, I think we're good. We've implemented our basic lighting like this actually. Another model here. Light. So then sphere. Call it another. How it looks like when not moving. My camera is so bad, by the way. I think we have direction following the specular. Let's see. Okay, this was it. The session was a bit short, but we have achieved some funk shading. Should be okay. And when I have the time, I will start with the material capital, and then after with lightning. See you around and have a nice